Hello everyone, welcome to Edupedia World Videos. In today's lecture, we will discuss about metallic bond and exceptions in physical properties of metals. Metallic bond. The metallic bond is defined as a bond formed by the simultaneous attraction of an electron by two or more than two positive ions of the metal. The examples of metallic bond are metallic bonds in lithium metal, sodium metal, potassium metal, and transition metals. And in order to account for the nature of metallic bonding and properties of metals, the electron C model has been proposed. The structure of metallic crystals reveal that each metal in a metallic crystal is surrounded by 8 or 12 other metal atoms. Since in metal atoms the number of bonding electrons we can also call bonding electron as valence electrons. It is usually only few. For example, for sodium it is 1, calcium 2, aluminium 3. And it is not possible for a metal atom to form 8 or 12 electron pair bonds with the neighboring metal atoms. Other than the bonding electrons of the metal, the bonding electrons of the neighboring metal atoms can come close to the proximity of its valence electrons. So there is complete freedom of movement of bonding electrons from metal to metal. The bonding electrons in metal atoms are delocalized and they are mobile, in contrast to the localized electrons in electron pair bonds. For example, hydrogen-hydrogen bond. The bonding electrons in any metal do not belong to a particular metal atom but belong to the metallic crystal lattice as a whole. Due to the localization of bonding electrons, the positive metal ions are formed. A metal behaves as it is an assemblage of positive kernels immersed in a sea of mobile electrons. Hence, each electron belongs to a number of positive ions and each positive metal ion belongs to a number of electrons. So, metallic bond can also be defined as the force of attraction which binds a metal atom kernel to a number of electrons within its sphere of influence. The metallic bond is weaker than the normal electron pair bonds, and as such we cannot call a metallic bond a chemical bond. And the strength of metallic bond increases with increase in number of bonding electrons. It increases with increase in number of bonding electrons and charge on the nucleus. And its strength decreases third point is it decreases in size of atom. Decreases in size of atom. Since alkali metal possesses only one bonding electron, the alkali metals are soft and have low melting and boiling points. The hardness and high melting and boiling points of transition metals are due to the presence of higher number of bonding electrons, higher nuclear charge, and smaller size. Now, these are the main points. The metallic bond is weaker than the normal electron pair bonds. And about the strength of metallic bond. The strength of metallic bond increases with increase in number of bonding electrons and charge on the nucleus, and with decrease in size of atom. We have already discussed these points. Now, exceptions in physical property. Elements cannot be classified into metals and non-metals on the basis of only physical properties. There are many exceptions in their physical properties, and some exceptions are: metals are usually hard, but alkali metals such as lithium, sodium, potassium, rubidium, caesium, they are very soft and they can be cut easily with a knife. The alkali metals exhibit low melting and low density. They exhibit low melting point and low density. The second point is all metals are solid at room temperature except mercury, which is liquid at room temperature. Two metals such as gallium and caesium, they also exhibit very low melting point. They melt when kept on compound. The third point is metals exhibit metallic luster, but the non-metals iodine and graphite, they are allotrope of carbon. They also exhibit metallic luster. Metals conduct electricity, but graphite, it is an allotrope of carbon, is also a good conductor of electricity. Metals are hard, but diamond, an allotrope of carbon, is the hardest natural substance known, and it exhibits very high melting point and boiling point. The above exceptions indicate that metals and non-metals cannot be classified on the basis of only physical property, but they can be more clearly classified on the basis of their chemical properties. We will discuss chemical properties in our next lecture. Thanks for watching Edupedia World videos.